Hi, in this video, I will be showing you problem number 9 of chapter 4 section 5 from the practice exam. Use the guidelines of this section to sketch the curve y equal to x over x minus 4. The first step is to find out the domain. In this case, this being a rational function, whenever the denominator is equal to 0, the function is undefined. So whatever value that makes the denominator equal to 0 is not part of the domain. So it is d all x such that x is not equal to 4. In the interval form, if you write the domain, it will be negative infinity to 4 and then union 4 through infinity. Then we will find out the X-intercept and the Y-intercept. X-intercept is obtained by setting y equal to 0. When you set y equal to 0, automatically the numerator is 0. So 0, 0 is the X-intercept. Then Y-intercept is obtained by setting x equal to 0. This implies that y equal to 0. So y-intercept is also 0, 0. Then we notice that there is, if there is any symmetry, we have to say where the symmetry is. Symmetry, we see there is no symmetry here because by changing x to negative x, the sign doesn't change, nor it remains the same. So there is no symmetry. And we have to find out the horizontal asymptote and the vertical asymptote. So which is obtained, the horizontal asymptote is obtained by setting, allowing x to approach infinity or negative infinity. So it's x over x minus 4. So dividing the numerator and the denominator by the highest exponent of the denominator. So I'm going to divide this by x, divide the denominator also by x. It will become limit as x approaching infinity or negative infinity, x over x minus 4, x divided by x, that would be a 1 minus 4 over x, and then this will become 0, 4 over x is a large number, so 4 over infinity will become 0, so this is equal to 1. This tells us horizontal asymptote is y equal to 1. Now, in order to get the vertical asymptote, because the denominator has x minus 4, we'll try to allow approach x from to 4 from the left side of 4 and the right side of 4. So when you allow it to approach from the left side of 4, x over x minus 4 would become negative infinity. And when you allow x to approach 4 from the positive side of 4, from the right side of 4, which means that x is slightly more than 4. So x over x minus 4 in this case would become infinity. So to the left side of 4, the graph is approaching negative infinity. To the right side of 4, the graph is approaching positive infinity. This tells us that the vertical asymptote is x equal to 4. The graph is increasing or decreasing, decreasing test. It decided by the first derivative. We will find out the first derivative by applying the quotient rule. So denominator times derivative of numerator minus numerator times derivative of denominator divided by denominator square. We get negative 4 over x minus 4 square. The denominator is always positive. The numerator is always negative. So this will be less than 0 whenever x is not equal to 4. Note that in the earlier we made a mention of 4 not being in the domain. So it's always negative for all values not in the domain. So we have to say f prime, f is decreasing on negative infinity to 4 and then 4 through infinity. So throughout the domain the graph is decreasing. So next part, so because it's only decreasing throughout the domain, it never increases in the domain, so there is no extreme value. So no local max or local min. No local max or local min. Next we have to see where it is concave up or concave down. That is determined by the second derivative. So if it is second derivative positive, f is concave up. When second derivative is negative, the graph is concave down. So we'll apply the second derivative. We already know the first derivative, which is negative 4 over x minus 4 square, and we are going to differentiate that. So f prime x is negative 4 over x minus 4 square, which can be written as negative 4 times x minus 4 to the power negative 2. So if you do the derivative here, we can write by chain rule negative 4 times negative 2 times x minus 4 to the power negative 3 times derivative of x minus 4, the inner derivative, that is 1, which will tell us, which will become 8 divided by x minus 4 the whole cube. So this is positive whenever x is more than 4, and then this will be negative when x is less than 4. So if you write 4 here, and negative infinity to infinity, if we divide the number line into two intervals, one between negative infinity to 4 and 4 through infinity, 4 through infinity it is concave up, the negative infinity to 4 it's going to be concave down. So concave up on 4 through infinity, concave down on negative infinity through 4. Usually we say wherever the graph is changing in concavity, that's where the inflection point is. But in this case, even though the concavity changes at 4, but 4 is not part of the domain, so we have to say there is no inflection point. Now the last part reminds us to sketch the graph. So we notice several things. X equal to 4 is not part of the domain, and also x equal to 4 is the vertical asymptote. Y equal to 1 is the horizontal asymptote. The graph also passes through the origin. So the graph passes through the origin, hugging the asymptotes, and it's concave up to the right of 4 and it's concave down to the left of 4. This is how a rough sketch of the graph would be. Hope this video helped.